Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 18th, 2026, just 4 days ago. It introduces a framework for continual learning that allows agents to adapt to specific user needs, boosting success rates in robotics and shopping tasks to about 70% compared to baselines that struggle between 36 and 54%. The paper is titled Learning Personalized Agents from Human Feedback. And as we'll see later, the results for handling users whose preferences change over time are really impressive. Figure 1 illustrates the core difference between traditional methods and this new framework. The top row depicts static personalization, where agents process offline logs once to build a fixed profile, represented by that locked database, meaning they cannot learn anything new after deployment. In contrast, the bottom row introduces the continual personalization approach. Here, the agent stays online with the user, actively reading and writing to its memory, which allows it to update its understanding in real time as it receives feedback. Figure 2 illustrates how this works over a 3-day sequence with a user named Kate. On day 1, the agent starts with no data, so it asks a pre-action question to establish that Kate likes Coke. On day 2, the context becomes more specific because she is sleepy, causing the agent to fail by serving Coke again. However, post-action feedback allows it to learn that sleepy actually means tea. Finally, day 3 shows true preference drift, where her taste shifts to coffee, which the agent captures through another round of corrective feedback. So figure 2 showed the concept. Now figure 3 presents results for the embodied manipulation task. The top row tracks phase 1, or initial learning, where the orange PAHF line quickly achieves high success. However, the bottom row, covering phase 3 drift, tells the real story. In the bottom left success chart, the blue pre-action line stays flat because the agent trusts its outdated memory and stops asking questions, visible in the low feedback frequency in the middle graph. Conversely, the green and orange lines recover rapidly, proving post-action feedback is essential to unstick the agent from stale beliefs. Figure 4 confirms these findings in the online shopping domain. The top row shows phase 1, where the orange PAHF agent leads in success. The critical result, however, is in the bottom row, which tracks preference drift. In the bottom middle chart, the blue pre-action line stays near 0, meaning the agent stops asking questions because it is overconfident in its old data. Consequently, its success rate in the bottom left plot flatlines, while the green and orange lines rise steeply as they use post-action feedback to adapt. Well, having seen the learning curves, Table 1 now summarizes the final success rates across both domains. The most striking result appears in the embodied Phase 4 column. Here, the pre-action-only model drops to just 35.7% success because it fails to adapt to preference changes. In contrast, the bottom row shows that PAHF maintains a robust 68.8%, outperforming all baselines. This dominance extends to the shopping domain as well, where the full framework reaches a clear high of 70.3%. Wrapping up, the key takeaway is that combining explicit memory with dual feedback channels is essential for long-term personalization. While asking questions beforehand prevents early mistakes, post-action feedback is the only way to catch and correct outdated beliefs when user preferences shift. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.